Systems of equations can also be used to set up matrix equations, and vice versa. Let's look at our first example. We're going to rewrite the system of equations, negative 3x plus 2y equals 9, and 5x minus 3y equals negative 13, as a matrix equation. The first thing I'm going to do is create a matrix using the coefficients from my equation, negative 3, 2, 5, and negative 3. This is similar to a 2 by 2 matrix that we would have created while we were doing Cramer's rule. Next, I'm going to multiply my 2 by 2 coefficient matrix by a 2 by 1 variable matrix using my variables x and y from my system. Finally, on the right side of my equation, I will make a solution matrix using my two solutions, 9 and negative 13. And I now have a system of equations that is represented as a matrix equation. Let's try another one. In our second example, we have a system of equations in 3 variables. So we will begin by creating our coefficient matrix. First, I'm going to use the coefficients from my x variable. Next, I'll use the coefficients from my y variable. And lastly, I'll use the coefficients from my z variable. Notice over here in my first equation that letter should be a z. Next, I will multiply my coefficients by my variable matrix, and my 3 variables are x, y, and z. And lastly, after my equal sign, I will write my solution matrix with my 3 solutions, 3, 2, and negative 5. If you want to check yourself to see if you have set up your matrix equation the correct way, I'm going to go back to my first example. Notice how on the left side of my matrix equation, we are performing matrix multiplication. So if you want to make sure that you've paired the correct coefficients with the correct variable, remember that we do matrix multiplication row by column. So if I were to check myself, first I would take negative 3 times x and add that to 2 times y. In my second row, I'd have 5 times x and negative 3 times y equal to both of my solutions. So if you want to double check yourself, you will now notice that the check that I have done in red matches my original system of equations, so that I know I have set up my matrix equations correctly. So next we're going to look at taking a matrix equation and rewriting it as a system of equations. I'm going to start with the first row of my matrix equation, and I'm going to multiply it by the column of my variable equation. 2 times g is 2g, 1 times h is h, and that is equal to my first solution of 0. For the bottom row of my matrix equation, I'm going to be using 3 and 2. 3 times g is 3g, and 2 times h is 2h, equal to my second solution of negative 2. So I have now rewritten the matrix equation as a system of equations. We're also going to look at how you can rewrite data as a matrix. So here I have data represented for the cities of Sydney, Australia, Harrisburg, Pennsylvania, and London, England, and their average temperatures in the months of July and in December. We're going to rewrite this data as a matrix, as a 2 by 3 matrix. So I'm going to begin by looking at the data for Australia. 46 degrees in July, 72 degrees in December, and I am making a 2 by 3 matrix. So those two values will represent the column. Next we'll look at Harrisburg, 83 degrees in July, 33 degrees in December. And lastly, London, England, average temperature of 66 degrees in July and 45 degrees in December. So now I have a 2 by 3 matrix where my columns are represented by the months of, the rows are represented by the months of July and December for each city. My first column represents Australia. My second column represents Harrisburg, and my final column represents London.